we'll talk about how to perform exploratory factor analysis. We call it EFA using spss. And what is the spss? It is a statistical software where the researcher use to analyze their factor, their data. This is a technique of factor analysis. Let's talk about, first we'll talk about the theory and then we'll discuss spss software and how to do EFA in this software. So we'll start. So first learn how to perform EFA analysis using the tutorial covered in detail. Number 1, concept of EFA. Second, difference between EFA and CFA. These both are the technique of factor analysis. The first EFA, we call it exploratory factor analysis, and CFA is a confirmatory factor analysis. Key terms in exploratory factor analysis: process of conducting exploratory factor analysis, reporting exploratory factor analysis. We'll talk about what is the factor analysis. Factor analysis is used as a data reduction technique. Second, factor analysis takes a large number of variables and reduce or summarize it is represent them in different smaller factors. Those factors are made up of the initial set of variables. Number 3, factor analysis is a method for investigating whether a number of variables of interest are related to a smaller number of unobservable factors. This is done by grouping variables based on intercorrelation among a set of variables. Number 4, those initial variables are the manifest variables, observed variables, while the factors that are extracted in the process are the latent variables. Number 5, a common use of factor analysis is in developing scale questionnaire for measuring the constructs that are not directly observed in real life. Number 6, the factor analysis technique primarily examines the systematic interdependence among a set of observed variables through the correlation, and those variables that have higher correlation are grouped together. Number 7, factor analysis helps the scholar answer the question that how well do the item go well together in case we are building a new scale. Let's talk about when EFA versus CFA will be applied. First, when applied to a research problem, these methods can be used to either confirm a prior established theories or identify data pattern and relationship. Specifically, they are confirmatory when test the hypothesis or existing theories and concept, and exploratory when they search for latent patterns in the data in case there is no or only little prior knowledge of how the variables are related. When exploratory factor analysis is applied to the data set, the method searched for relationship variable with high correlation are grouped together between the variables in efforts to reduce a large number of variables to a smaller set of composite factors, that is combination of variables. In the final set of the composite factor is a result of exploring relationship in the data and reporting the relationship that are found, if any. In simple words, EFA is an exploratory technique that is utilized in research to group a large number of variables, observed variable, into the smaller presentative factors, latent factors, whereas CFA is utilized to test a particular set of relationship based on some theory and to ascertain the data with the proposed model in an adequate manner. let's talk about basic terminologies in a factor analysis. The following is the list of some basic terms frequently used in the factor analysis. Number 1, Kaiser-Meyer Olkin, we call it KMO, measurement of sampling adequacy. So in the factor analysis, whenever the researcher will do the EFA, so first the researcher check KMO. KMO should be greater than 0.50. Let's talk about the Kaiser-Meyer Olkin KMO measurement of sampling adequacy is a statistical use of examining the appropriateness of the factor analysis based on the sample of the study. A higher value of from 0.05 minus 1 indicates the inappropriateness of the factor analysis for the data in hand, whereas a low value of the statistic below 0.5 indicate that inappropriateness of the factor analysis. This means that sample is not enough for EFA. So if KMO less than 0.5, so the sample is not appropriate. If it will be more, then the sample will be appropriate. Second, Butler test of sparsity. Butler test of sparsity is a test statistical used to examine the hypothesis that variables are uncorrelated in the population. In other words, the population correlation matrix is an identity matrix. Each variable correlated perfectly with itself. R is equal to 1 but has no correlation with the other variable. R is equal to 0. A value less than 0.05 indicate that the data in hand do not produce an identity matrix. As with an identity matrix, factor analysis is meaningless. This means that there exists a significant relationship among the variable. A significant result greater than 0.05 indicates matrix is not an identity matrix, that is the variables to relate to one another enough to run a meaningful EFA. And then commonality. Commonality is the amount of variable a variable shares with all the other variables being considered. Small value indicate variables that do not fit well with the factor solution and should possibly be dropped from the analysis. Normally value less than 0.50 are removed. After that, percentage of variance. It gives the percentage of variance that can be attributed to each specific factors relative to the total variance in all the factors. Eigenvalue. The eigenvalue represents the total variance explained by each factor. Factors have eigenvalue over the one are selected for further study. Screen plot. It is the plot of eigenvalue and the factor number of according to the order of extraction. This plot is used to determine the optimal number of the factors to be retained in the further and final solution. Factor loading, also referred to as the factor variable correlation. Factor loading are simple correlation between the variables and the factors. Factor loading shows how well the items represent the underlying factors, and factor matrix contain the factors of all the variables on all the factors extracted. Here is the rotation method. What is the rotation method? It is the part of the EFA, makes the loading pattern easy to understand in the rotation method. Normally researcher use Varimax, most common rotation method, and in the Varimax minimize the number of variables with extreme loading, higher or low. On a factor minimizing, the correlation between the factors makes it possible to identify a variable with a factor. Components are always orthogonal. Each component explains non-residual information. Direct oblimin, DO factors are allowed to be correlated. Rotation that allow for the correlation are called oblique rotation. Rotation that assume that factors are not correlated are called orthogonal rotation. Very mixed return factors that are orthogonal oblique allow the factors to not be orthogonal. Let's talk about the process of conducting the factor analysis. There are 8 steps. Number 1, problem formulation. When the conducting the factor analysis, researcher first look for the problem formulations and then EFA requirements. After that, appropriate factors technique. Researcher decide which technique will be suitable for according to your data and according to their research. Decision regarding number of factors, factor rotation, model fit, running EFA analysis, interpretation and rotating reporting. Step 1, problem formulation. So we are reading about the factor analysis. Step 1, what is this? This is the problem formulation. In first step, in conducting the factor analysis is to formulate the problem of the factor analysis. As discussed earlier, the main focus of the factor analysis is to reduce data. For the purpose, a researcher also to select a list of variables that will be converted into a new set of the factors based on the common essence represent in each of the variables. For selecting variables, a researcher can take the help or literature, past research, or use the experience of other researcher or executive for more on scale development process. It is important to note that the variable should be measurable on a interval scale of ratio scale. Another important aspect of the factor analysis is to determine the sample size which will be used for the factor analysis. As a thumb rule of sample size should be 4 or 5 times of variable included in the factor analysis. Step 2, EFA requirements. So after finding the problem formulation, EFA requirements is required. Analyzing the correlation among the variables. If there is no correlation among the variables or if the degree of correlation among the variable is very low, then the appropriateness of the factor analysis will be under the serious doubt. In the factor analysis, a research expect that some of the variables are highly correlated with each other from the factors. KMO has presented the range of the greater than 0.9 is marvelous, 0.8 meritorious, 0.7 middling, 0.6 mediocre and 0.5 miserable. So 0.5 unacceptable. KMO 0.5 is unacceptable. Bartlett test of the sparsity test. The hypothesis whether the population correlation matrix is an identity matrix. The existence of the identity matrix put the correctness of the factor analysis under suspicions. P-value less than 0.5 shows that population correlation matrix is not an identity matrix. The commonalities describe the amount of the variance or a variable share with the all variables take into the study. Relatively small value of the commonality such as that concerned variable is a misfit of the factor solution and should be dropped out from the factor analysis. And after the EFA requirements, the step 3 is factoring techniques. The principal component method is the most commonly used method. Data analysis in the factor analysis model. When the objective of the factor analysis is to summarize the information in a large set of the variables into the fewer factors, the principal component analysis is used. The main focus of the principal component method is to transform a set of interrelated variables into the set of uncorrelated linear combination of these variables. This method is applied when the primary focus of the factor analysis is to determine the minimum number of factors that attributes maximum variance in the data. The obtained factors are preferred as the principal component. Step 4, number of factors. Eigenvalue. A the eigenvalue is the amount of the variable in the variable taken from the study that is the associated with the factor. According to the eigenvalue criteria, the factor having more than one eigenvalue are including in the model. Screen plot is a plot of the eigenvalue and component factor number of according to the order of extraction. The shape of plot is used to determine the optimum number of the factors to the retained in the final solution. The objective of the screen plot is to visually isolate an elbow which can be defined as a point where the eigenvalue from the linear descending trend. Percentage of variance criteria. It gives the percentage of variance that can be attributed to the each specified factor relatively to the total variance in all factors. This appropriate is based on the concept of the cumulative percentage of the variance. The number of factors should be included in the model for which cumulative percentage of the variance each a satisfactory level. The general recommendation is that the factor explained 60 to 70% of variable should be retained in the model. So this is the important part. The number of factors should be included in the model which cumulative percentage of the variance reaches a satisfactory level. The general recommendation is that the factor explaining 60% to 70% of the variance should be retained in the model. Let's talk about the step 5, that is the factor rotation. After selecting the factor, the immediate step is to rotate the factors. The rotation simple structure solution are often easy to interpret, whereas the originally extracted unrotated factor are often difficult to interpret. A rotation is required because the original factor model may be mathematically correct but may be difficult in terms of interpretation if various factors have a higher loading of the same variable, then interpretation will be extremely difficult. Rotation solves the kind of interpretation difficulty. The main objective of the rotation is to produce the relative simple structure in which there may be highly factor loading on one factor and low factor loading on all other factors. The widely applied method of rotation is the Varimax procedure. Although a number of rotation methods have been developed, Varimax has been generally regarded as the best orthogonal rotation as the overwhelmingly the most widely used orthogonal rotation in the psychological research. Here is a step 6, that is the model fit. The last step in the factor analysis is to determine the fitness of the factor analysis model. In the factor analysis, the factors are generally of the basis of observed correlation between the variables. The degree of the correlation between the variables can be reproduced for an appropriate factor analysis solution. That difference between the reproduced and observed correlation should be smaller, less than 0.05. As a rule of thumb, a model that is a good fit will have less than 50% of the non-reductant residual with the absolute value that are greater than 0.5. Here is the step 5, running the EFA analysis. The problem investigate if there is any smaller number of unobserved factors in the 19 variables that are measured. University social responsibility of which the data is available. The example based on the skill development initial item identified to measurement university social responsibility world 19. The researchers would like to assess if there are any underlying dimensions. Step to run the factor analysis. Number first, choose the analysis, dimension reduction and factor. So first go here to the analysis and then dimension reduction, and after that factors. Select the variable from the left hand side box and transfer them into the box label. So when you click the factors, after that this image is visible, so you will select your all the variables and then drag it there, and after that there is the option of the first option, we call it descriptive. In descriptive options, you will select the initial solution, coefficient and KMO. If you want others results such as reproduced, inverse, anti-image, significance level, so you may also select this. And after that, this the second is here the option after doing the factors. The second option is the explanations. Here extraction, you can use principal component factors. This is the widely used method, and you may select others methods also. It's up to the scholar. And after that, the third is when you will select turn on the correlation matrix and unrotated factors and skill plot you can change manually according to your uh, choice. And after that, factor analysis rotation, where most of the researchers select the varimax. It is widely used, and you may also select quarter matrix, equimatrix. It's depend on your data and depends on what's uh, type of rotation you wanna select. And after that, there is the finally click on the button label, and you click where you select absolute value below point. All usually select below 0.50. You may select below 0.40 also. And after that, put click it OK. And then an EFA was performed using the principle. Here is the explanations of all the data which gather by using spss. So we'll read about the. An EFA was performed using the principal component analysis and varimax rotation. The minimum factor loading criteria was set of the 0.50. The commonalities on scale which indicate the amount of the variance each dimension was also acid and ensure acceptable level of explanation. The result shows the all commonalities over the 50. An important step involve weighting of overall significance of the correlation matrix through the Bartlett sparsity, which provides a measurement of the statistical probability of the correlation matrix. The significant correlation among sum of the component. The result was significant. X square n is equal to 215 is equal to 2013.29. 2p less than 0.001, which indicate the suitable for factor analysis. The Kaiser-Meyer KMO measurement of sapling adequacy, MSA, which indicate the appropriateness of the data factor analysis, was 0.931. Disregard data with MSA value of 0.0800 are considered appropriate for factor analysis. Finally, factor solution divergence analysis yield the scale of amounted 57.753% of the variations of the data. Nonetheless, in the initial EFA, two items RDR1 university involved and the PR1, these items failed to load any dimension significantly. So these students are educated regarding their social responsibility in their area and specialized load and into the factor and the underlying factor. Hence, three items were removed for further analysis. The authors repeated the EFA without including these items. This result of new analysis confirmed the 5 dimensions structures theoretically define the result. See the table. The KMO and the dimensions explained the 60.798% of the variance among the study. The Bartlett sparsity provided significance all the commonalities and required value 0.500. The four factors identify the part of the EFA aligned with the theoretical proposition and research. Factor 1 including ER1 to ER7 referring to the ethical responsibility. Factor 2, this is referring to the dimension, and this is referring to the philanthropic responsibility. So here is the item ER1 to ER7, the table 1 EFA result, research and development, and the philanthropic responsibility. For the explanatory factor analysis, here is you may read these AS and Gore SS 2006 for the research. So here is all about the EFA and factor analysis. I hope this video is useful for you.